I welcome everyone. I'm Uma Maheshwari, AP AAA Department, R&D Engineering College. Today's session, I'm going to discuss the subject Power Electronics. The subject code is E8552 and the Unit 3 DC to DC chopper. Let us move to the topic. Today's topic, chopper. What is a chopper? The chopper is a circuit where we are able to convert fixed DC to variable DC. Okay. So the converting the unregulated DC input to a controlled DC output with the desired voltage level is known as chopper. So this is the general block diagram definition of the chopper, where the input is the DC supply. So the DC supply can be from a rectifier, filter, battery, or a fuel cell, and this input is given to a block where the conversion is happening. Chopper circuit conversion is happening. The output is the DC output. The DC output which is given to the DC load. So the output we are obtaining, we are able to control it. The control is given with the help of the V control, which is derived from the feedback circuit. So we are able to control the output voltage, DC output voltage, which can be controlled. Such an output chopper is represented by a switch like this, and the power semiconductor devices which is used for chopper circuit are power BJT, power MOSFET, and GTO, IGBTs. So these are the devices we mainly use in chopper circuit. So what are the devices which are used in low power applications? For low power application we prefer GTO, IGBT, power BJT, power MOSFET, etc. Whereas for high power application, we use thyristors or SCR. Now, we have the different types of choppers: step down chopper and step up chopper. So here the chopper can increase or decrease the DC voltage level, okay, at the output end. So the chopper which is used to convert the voltage from a lower value to higher value is known as step up chopper. Okay, and the step down chopper is also possible. Okay, this output voltage can also be step down. Such a chopper is known as step down chopper. Okay, here you can see the fixed DC input is converted into variable DC output. So this is general diagram representation where input is fixed and which is given to a DC-DC converter, and the output voltage is variable. Now, as I already told you, the types of chopper is represented in this slide. So it is step down chopper and step up chopper. So in case of step down chopper, the output voltage is lesser than the input voltage. Whereas in case of step up chopper, the output voltage is more than the input voltage. So here you can see that the expression in terms of V output and V input. The step down chopper is also known as buck converter, where V output is lesser than V input. The output voltage is lesser than input voltage is known as step down chopper or buck converter, and the output voltage is greater than the input voltage is known as boost converter, or it is also known as step up chopper. So we have one more, the other converter is known as buck boost converter, where we are able to obtain the output voltage which is lesser than the input voltage, or we are able to obtain the output voltage which is greater than the input voltage. So we are able to do both buck mode of operation and boost mode of operation in buck boost converter. So the main function of chopper is in order to obtain the adjustable DC voltage, and we are able to obtain a good regulation of the output voltage. Now we'll move to the discussion of step down chopper with circuit diagram and its working operation and the waveform, output voltage waveform. Now, step down chopper is also known as buck converter, I'm repeating, it is used to repeat. It is used to reduce the input voltage level at the output side, which means that V output is lesser than the Vs. Wherever load, we require a variable voltage, and that voltage is lesser than the input voltage. So we go for step down chopper. So we see the circuit diagram of it. This is the circuit diagram of step down chopper. Vs is the supply voltage and is connected to a switch, which is the chopper here. The switch can be in either an IGBT or MOSFET or an SCR. Okay, and the freewheeling diode is connected. FD represents the freewheeling diode, and the switch end is connected to the inductance, and the other end of the inductance is connected to the load. The current through the load is represented as I naught, and the voltage across the load is represented as V naught. So this is the circuit diagram of step down chopper. So there are two modes of operation, mode 1 and mode 2. Mode 1 operation is when the switch is in on state. So we'll see the mode 1 operation. So in mode 1 operation, the switch is in on state. So switch is in on state means CH is in on, which means that the switch acts as a closed circuit. Here, since it is a closed circuit, we have drawn the switch in the closed circuit manner. So when the switch is in on condition, how is the power is flowing? So from the source, positive of the source through the switch, through the inductance, and to the load, and to the negative of the supply. The power is flowing from the source towards the load. The inductor gets charged during this interval. The inductor current increases from I1 to I2. The inductor current increases from I1 to I2. And what about the output voltage at this interval? So the output voltage at this interval is V output from instant 0 to t. So it is the t on interval. The 0 to t is known as t on interval. The switch is in on condition. T on interval. So during this T on interval, the source voltage is same as that of the output voltage. So the output voltage magnitude V output is equal to Vs. So during the switch on condition, we are obtaining the output voltage, and the output voltage magnitude is equal to the Vs value. So this is your mode 1 operation. Now when the switch is in off state, so when the switch is in off state, it is acting as an open switch. So it is an open switch. There is no connection between the source and the load. So in this circuit, what is happening? How the power is flowing? That is during the off period of the switch. So during the off period of the switch, here you can see that whatever energy stored in the inductance is freewheeling through the short circuit path. So because of the polarity of the inductance, minus connected to this freewheeling diode cathode, and positive connected to this freewheeling diode anode. The freewheeling diode gets forward biased. So see, previously you can see the polarity of the inductor in mode 1 operation. It is plus here and minus here. And because the sudden reversal of the switch condition, the polarity of the inductor changes. And with respect to the polarity of this inductor, the freewheeling diode is forward biased, and there is a short circuit path created. So whatever energy stored in the inductor is freewheeling in this short circuit path. So the current is reducing from I2 to I1. Here you can see the output current is reducing from I2 to I1. So this is during the mode 2 operation. And what is the output voltage across this short circuit path? So output voltage across this closed loop is short circuited path is 0. So here you can see that during the off state of the switch, T off is off, the output voltage is 0. And after this T off interval, again the cycle repeats, T on period. So during the T on period, output voltage is equal to Vs, and then again T off period. The repetition of this cycle takes place. So the total time is T on plus T off. It is represented by T. Okay, so chopping period, it is T on plus T off. It is represented by symbol T. T on is the on period of the switch. T off is the off period of the switch. So during this mode 1 operation, now we will see the output voltage expression for step down chopper. So the average output voltage is equal to V output is equal to. So during the on period, what is the voltage level? It is equal to Vs. So Vs into T on divided by the total period, which is nothing but T on plus T off. So this can be written as T on by T into Vs. So what is alpha? Alpha is nothing but this ratio of T on by T duty interval. So alpha is equal to T on by T duty cycle. So I can write V naught is equal to V naught is equal to alpha into Vs. What is alpha? T on by T. This 1 by T can also be written as F into T on into Vs, where F is equal to 1 by T chopping frequency. So the average output voltage of step down chopper is alpha into Vs. And here you can see that the output voltage, whenever we take the duty cycle of D as 25 percentage, that is 0.25, we substitute in the output voltage expression obtained. V output is equal to alpha into Vs, alpha or D, it is substituted as 0.25 into Vs. So we are able to understand that the output voltage is lesser than the source voltage for different values of duty cycle in case of a step down chopper. So we are able to conclude that output voltage is always less than the input voltage, and hence we name step down chopper. Thank you everyone.